Now we'll start with the second part of predicting redox reactions, when we actually have a reaction and then we are predicting what is the redox reaction, and is this a spontaneous or not? Like, what is the product of the redox reaction? Okay, so now we have this. An acidified potassium permanganate solution is added to sodium iodine solution. What is the redox reaction? Now, in order to do this, we will implement some steps. And the very first step will be to identify the species that are in this reaction. So when we are using the word acidified, what do we have? So when we see the word acidified, is that means that we have hydrogen ions. So the very first species will be hydrogen in aqueous solution. Okay, and then potassium permanganate. So when you see your periodic table, potassium and permanganate permanganate, first of all, is in your uh, table of common polyatomic ions. So permanganate is MnO4, and when you see it as MnO4 is -1. So when we have a solution, what is happening in this ionic compound, so sorry, KMnO4 is an ionic compound. What it is happening, it is broken down into ions. So we have the potassium ion, so K plus, in aqueous solution. We have permanganate ion, MnO4 minus, in aqueous solution. And since it is in water, is a solution, then we have water there. Okay, so up to now we are here. Okay, we are to this part of the lesson, of the question. Is added to sodium iodine. So if we take a look at sodium iodine, is the formula for it is NaI. Okay, and even this is an ionic compound, because we see that is sodium, which is a metal, and iodine, which is a non-metal. They are combined together to form an ionic compound. So when it is dissolved, dissociated in water, what do we see is sodium 1 plus in aqueous solution and iodine minus in aqueous solution. And then this is a solution, which means that is water, but we have water here, so we don't have to double the listing the water here. Okay, so the very first step is to identify all the species that are in this reaction, participating on this reaction. The second step will be to identify if it is a oxidation agent, so it is reduced, or if it is a reduction agent, so it is gaining electrons, or it's both. So if it is an oxidation agent, that means oxidation agent is reduced. So oil rig is reducing, is losing electrons. Okay, so when we see hydrogen here or potassium, then we think that what is happening is oxidation agent. Okay, so identify, the step 2 will be identify oxidation agent. Okay, and we can see it even on the table. Okay, when we see it, we see hydrogen. Where is hydrogen here? Is this one here. So it is H plus is an oxidation agent, because what do we have on this side is oxidation agent, and what do we have on this side are reducing agent. Okay, so oxidation agent is on hydrogen plus is on this side. Potassium is an oxidation agent as well. And permanganate is included, is together with water. When we take a look at it with hydrogen, not with water. When we take a look at it, we see permanganate and hydrogen right at the top of the table as the oxidation. Okay, so this one plus this one will be an oxidation agent. And then when we see water, water is in both sides. Water is, where is water now? So the table is telling us that water is in both sides, is somewhere in here and in here. So that means that water is both oxidation agent and reduction agent. Okay, and then we move to sodium ion. And sodium ion is an oxidation agent because it is on the side of the oxidation. This table is so small so that I can not see it. I have to go to my hard copy. So sodium ion is an oxidation agent. And when we see iodine is a reduction agent, and it is right here. Okay, so iodine is a reduction agent. So this will be the first step. Just have to be careful to see if there is a combination of the two. So in this case, what we had was hydrogen ion and permanganate ion will be combined together, and they are right at the top. Now, the second step will be, or the third step, sorry, the third step will be to identify which one is the strongest oxidation agent and strongest reacting agent. Why are we doing this step? Is because we want to see, so this is what we have here. We have a bunch of reduction agent and a bunch of oxidation agent, but we want to see who has the highest power, quote unquote, to react together, because not everything will react. They will be, but not in terms of the prediction or redox reaction. So we have to take a look and see which one has the highest power, meaning that which one is on the oxidation agent side of the table, on the left side of the table, which one is at the top, and for the reduction, which one is at the bottom for the reduction side of it, for this side of it. Okay, so when we see it, we notice that permanganate and hydrogen is at the very top of every species that we have here, and the iodine is at the very bottom of the species that we have here, because water is here and iodine is here, so this is the strongest reduction agent, and those two are the strongest oxidizing agent. Okay, great. Now, what we do is we take those reactions, and this is the fun part of it. We don't even have to think about it anymore. What is the reduction? What do we have to do? And all that stuff. But so step 4 will be to write the half reduction, half reaction reduction, and half reaction oxidation. So the very first thing, so write half reduction and half oxidation reaction, which are taken from the table. So you don't even have to do anything. For the reduction, you will take it as it is. So you will go half reduction reaction will be, sorry, MnO4 as you see it on the table. So MnO4 minus in aqueous solution plus 8 hydrogen. You don't even have to balance it, guys. It's fine. It is balanced for us. Plus 5 electron, and the reaction goes in this side because it is a reduction reaction. Will be N2 plus in aqueous solution, of course, plus 4 water liquid. Okay, this is half reduction reaction. And half oxidation reaction, this is a bit tricky, quote unquote. Half oxidation reaction will be now going in the opposite direction. So what do you see here is I2 solid plus 2 electrons gives you 2 iodine ion. Okay, what do you do now? Since it is the oxidation reaction, you will write it on the other direction. Okay, you will write it on the other direction. You will say now that two iodine in aqueous solution will be H solid plus 2 electrons. Okay, so now that we have half reduction and half oxidation reaction, what we do is we combine the two to create or to predict the redox reaction. Redox means that is reduction and oxidation reaction. In order to do that, though, what do we notice is that we have 5 electrons in the half reduction reaction, and we have 2 electrons in the half oxidation reaction. So we have to make them the same in order to cancel them out. In order to do that, what we do is we find that is known as the common multiple of the two numbers, 5 and 2 in our case. And the common multiple of 5 and 2 is 10. So what do you have to multiply the half reduction reaction by to make it 10? 10 electrons, you have to multiply it by 2. And what do you have to multiply the half oxidation reaction by to make the electrons 10 is multiplied by 5. So now you have 2 half reduction and oxidation reactions that look like this. So this is the fourth step, okay? So 2MnO4 plus 2 times 8 is 16 hydrogen plus in aqueous solution, and this is in aqueous solution as well, plus 10 electron, because 2 times 5 is 10 electrons, so we'll give you 2Mn2 plus in aqueous solution plus 2 times 4 is 8 water in liquid. And then when we move to half oxidation reaction, that we are multiplying it by 5, then we will have 2 times 5 is 10 iodine ions, will be 5 in aqua solution plus 10 electrons. We do this because the number of electrons that are one in the reactant and one on the product, when we add them together, need to be cancelled out. Whatever is released is gained. Okay, so the final reduction reaction will be 2MnO4 minus in aqueous solution plus 16 hydrogen in aqueous solution plus 10 iodide will give you 2Mn2 plus in aqueous solution plus 5I2 in aqueous solution plus, I think that this is solid. This is solid, not aqueous. Solid plus 8 H2O in a liquid. And this will be the redox reaction. Okay, so their first step will be list all the species. List all the species. Present, as we did. Second one will be identify oxidation agent, reducing agent, and if there is any that is both, then identify them both. Then, based on the position that oxidation agent has and reducing agent have, find which one is the strongest oxidation agent and strongest reduction agent, because those are the two that will participate in the reaction. Then when you write the half reduction and half oxidation reaction, you have to see and look how can you balance electrons and write the equation. Add those two, and which means predict the redox reaction. Okay, we'll do more examples like this in class, but just take a look at this question, and then I will move to another one which is a bit more complicated.